Are you tired of power surges damaging your sensitive electrical equipment? This problem isn't going away either. We're seeing more automation, more surge problems, and more downtime. In this episode, we'll cover surge protection devices, how to select the right units, where to put them, and why installation is so important. Hello and welcome to the Power Grid, the podcast that helps you build reliability in your electrical system and gives you confidence in power. I'm Brian Brannigan with Power Protection Products, where we've been solving power quality problems for almost 30 years. Okay, I'm going to start with the story of how I made my first surge suppression sale. It was actually a factory warranty call. I was sent out to a wastewater treatment plant that had purchased a surge suppressor unit that had failed. We could tell that it failed because the indicator lights weren't working on it anymore. So the facility manager took me to the service entrance of one of their buildings where the surge suppressor was mounted. And we took down the model number and the serial number and verified that it was replaced under warranty. But while we were there, he also showed me some other areas of concern for surge suppression. He took me to the motor control center where all these motors were starting and stopping. He took me over to some PLC cabinets where it was monitoring various flows and processes in the system. He took me over to the sampler where it actually took a sample of the water and documented the water quality over time. And as our relationship grew, he took me to other buildings, other places that needed surge suppression. And we ended up doing a system survey or providing a system shield for his entire electrical system at all of his different facilities and lift stations, pump stations, digester buildings along the way. And I tell you this story because this is sensitive equipment that was operating in a very harsh electrical environment, and the surge suppression that we installed solved a lot of his problems. He told me one time that he used to pull his hair out every time there was a thunderstorm. But now, after he put all the surge suppression in, he doesn't even know when it's raining. So today we're going to talk about surge suppression. And one of the things I want to start with when we talk about surge suppression is the timeline for surge suppression. When we got into this business back in the late 90s, when we went to the water treatment plant, there weren't a lot of UL rules and regulations and testing for surge suppression, and it certainly didn't exist at all in the NEC code. But over time, Underwriters Laboratory, or UL, got better at passing UL 1449, UL 1449 second edition, and all the way up to today's standard of UL 1449 fifth edition when it comes to testing and qualifying surge suppression. Not only that, but now the NEC code is also referencing surge suppression and requiring surge suppression in 8 different places in the NEC code. So we're going to talk a little bit about power surges, surge suppression, which types to use for what sort of application. First of all, most of the surges that happen in your facility are coming from the equipment inside the facility. Motors, pumps, air compressors, conveyors starting and stopping, chargers charging. Anything going through a motor control center probably is going to be creating power surges that are going to go into the other equipment that's operated off of that same motor control center. 80% of your power surges are generated inside your facility. How do you know that? Some of the problems related to power surges are things like the premature equipment failure, long-term cumulative equipment damage, data loss, resets, operation shutdown, expensive equipment repair and replacement cost. If you're blowing circuit boards, you probably have an internal surge suppression problem that we can solve. You can actually take a look at motor windings. If a failed motor will show signs of surge suppression damage on one of the legs on the winding. Another more recent source of surge protection requirements, or another source of surge generators, are LED lighting. LED lighting will generate all sorts of power surges in the lighting panel. It's a great idea to put a surge suppressor on that LED lighting panel, especially if you're in a retrofit environment where you have a variety of old equipment married with new equipment. Surge suppression will not remove the entire surge. It'll knock down most of the surge, but there will be some residual surge that gets through a surge suppressor. Most of our testing at UL is done with 6,000 volts, but if you hit the best surge suppressor in the industry with 6,000 volts, you're still going to leak about 600 volts past it into the rest of the equipment. And that's why it's important to cascade your surge suppression. Your surge suppression needs to start at the service entrance, go into the distribution system, the control panels, and go all the way down to where the circuit boards are. Most circuit boards have some form of surge protection on them, known as an MOV, or metal oxide varistor. These metal oxide varistors degrade over time. Every time they take a hit, they degrade. They let a little bit more surge past it. Then a little bit more damage goes into your equipment. So by putting surge suppression on the panels feeding that equipment, you're actually protecting those circuit boards from the power surges. Eventually, the warranty of the circuit board will dictate how much surge suppression is built onto the circuit board. The current edition of UL 1449 requires a type classification for a surge suppression. Type 1 for surge suppression that's coming on the utility side of the service entrance, and Type 2 for the surge suppressors downstream from the service entrance or on the service entrance, but not on the utility side. It's very important that we mount our surge suppressors as close with the leads as straight as possible. There's a rule of thumb that for every inch of lead length on your surge suppressor, you're allowing 20 more volts to get past your surge suppressor. So if you only put surge suppression at the main service entrance, you can imagine how much lead length some of your downstream equipment would have to go through in order to get that surge suppressor to operate. You don't have to take my word for it. This is right out of the IEEE Emerald book, where they even show you pictures to put surge suppression at the main, at the sub panels, and all the way down to the load. Now, we mentioned the NEC code a little bit earlier in this podcast. The NEC code now references surge suppression shall be required in 8 different places in the code book. Most of these places are in areas that have to do with the protection of people. If we're moving people on an elevator or an escalator, we have to have surge suppression on the panels feeding that equipment. If we're protecting fire pump controllers, we have to have surge protection on that equipment. You would be surprised at the number of fire pump controllers that fail because of lack of surge suppression. If you think about it, a fire pump is something you only test and need very rarely, but you want that thing working when you do need it. So the code now requires you to put surge suppression on fire pump controllers. Another area of surge suppression requirement more recently is on equipment, particularly the equipment that have safety interlocks, where you have to put one hand in one area and another hand on another area in order to get the machine to operate. That machine has to have surge suppression on it to protect the safety mechanisms of those interlocks, and that's required by code now. Also, residential dwelling units recently have been required to have surge suppression by the NEC code. So any sort of dwelling, whether it's a house, an apartment, or a condominium building, is required now to have surge suppression on it. Now, surge suppression today is getting much smarter and smarter. We now have surge suppressors that can not only recognize the power surge, but date and timestamp the power surge, document which phase the power surge came in, classify the power surge as small, medium, or large, and also tell you what kind of life you have left on your surge suppressor. Because remember, these things deteriorate every time they take a hit. So it's important to monitor the life of your surge suppressor as well. So getting the right unit for the right application is very important for surge suppression. Things like peak surge capacity. How big of a power surge can the surge suppressor stop? How much voltage gets past the surge suppressor are things you need to think about in order to get the right application. The lower the peak surge capacity in a surge suppressor, the shorter the life of the surge suppressor. But if you put a good 250,000 amp surge suppressor on a service entrance, as you go downstream into the electrical system, you can start to put in lesser peak surge capacity units, a 160,000 amp surge capacity unit down on a motor control center, or even an 80,000 amp or 48,000 amp surge suppressor downstream at some of the panels. And then don't forget about the control power inside some of those cabinets. Oftentimes we run 480 volts to a cabinet. We step it down to 120 volts or 24 volt DC, and we'll have to put surge suppressors down at that lower voltage level as well. If we stop a surge at 480 volts, we're likely to leak enough voltage past that surge suppressor to damage those circuit boards if we don't cascade the surge suppression and go down to the actual control power feeding the circuit boards. So surges are going to happen. Get ahead of the damage by installing surge protection. It's the least expensive way to improve the power quality of your facility. Thank you for joining us today on the podcast. If you want to protect your facility from power surges and avoid downtime, plan a free site survey and power quality analysis for your facility by contacting P3 today. The phone number and the link are in the show notes of this episode.